Good evening. So please sign into Socrates for the attendance today. And while you are signing in, let me oh, there are still people joining. Let's people in. Okay, for those who are just joining, please sign into the Socrates for attendance. So, okay, so let's first, let me make sure I'm recording. Yes, I'm recording. Okay, so let's first review what we learned in the last couple of lectures. In chapter 1, we learned how to explore a data set loading to R as a data frame. And we also learned some basic R syntax, how to index in a data frame. In chapter 2, we learn how to manipulate the data frame, and we use differ to modify the cumulative COVID-19 case into daily cases. We also learn to do a simple plot and also recognize hidden bias in the data set. And most importantly, we learn how to verify the result using independent approach, and we learn how to do not. I'm sorry, I just realized I have to turn the projector on. I guess you are looking at the computer. So yeah. Okay. So we learn. Oh, there are still people joining. So let me let them in. Okay. Hopefully, oh, there are still people joining. Okay. Okay. Hopefully, that's all the students joining. So how to learn to verify the independent computational result independently, probably the most important lesson we should remember. In chapter 3, which is not yesterday, Monday, and we learn how to retrieve Google mobility data, and we merge it with the COVID-19 data. We also learn how to stack the data. Actually, that's a question I will ask you in a few minutes. So before I move on to today's lesson will basically do additional data analysis. We're going to retrieve the weather data, integrate the weather data with the Google mobility and the COVID-19 data set. And then we also learn how to calculate the group mean from the data frame using group by. And we're also going to identify the locations of latitude and longitude, and also going to properly do overlay using ggplot, using scaled and non-scaled values. And that's actually is a question some of you raised the last time. So that's today's learning objective. Before I go over that, let's review some of the concept I went last time. So I'm going to open up a short quiz, and you can just answer it. So let me open up a short quiz. So you are giving a data frame. You are giving a data frame TB. How would you find out what are in row 100, 105, and column 5 and 9 using R? This is just, again, repetition. Hopefully, this time I see 100% correct answer. So, yeah. So. Okay, 10 people, good enough. Okay, there are still a few errors. R use the square bracket, not smooth parenthesis. So Python uses smooth parenthesis. Yeah. So this it would be correct if the parentheses are square outside. So yeah, majority remember to use. Yeah, that's, I guess 70% are perfect answer. Yeah, that's good enough. Okay. So, but I guess there are a few, where is that? A few of those smooth ones that seem to be kind of a bit mixed up with Python. So, okay, next question. So how would you stack two compatible data frame in R? This is basically a review of last lecture. Last lecture, we retrieved the Google mobility data of 2020 and 2021. Now, Google actually put that mobility data into two separate files, separate basically a spreadsheet, and we have to stack them. How did we stack them? So just to see how many of you still remember it. While I'm talking, my mask is falling off. Oh yeah, very good. Many of you remember it. If we use a row bind because the Google apparently make the column exactly the same, so we can just really stack it using a row bind. So very good. Yeah. Okay. By row. Yeah. Oh, there's one wrong answer. C bind not to be wrong. Yeah. C bind on column. Yeah. So this is actually a general answer, but C bind will be a wrong answer. Yeah. Okay, so next one. So how would you merge two heterogeneous data frames? Like a Google mobility and COVID daily cases. Those are two different kind of data. How did we merge them? Although the question is a bit more general. So if you have two different data sets, let's say consumer review and then consumer review on product, and then you have the product price. You need to put these two data sets. The consumer tend to have better review for pricey product or a less expensive product. So maybe people spend more, they will have more higher expectation. Yeah. So, we could column bind on the though that we don't really do a column bind in that way actually. That would be very difficult. Merge is actually when you use the merge, actually you need something else. You can do a full join, yes. By name, I guess, yeah. Basically, I'm trying to see. Oh yeah, this is actually you need to find a variable which can be used as the primary key between the two data frames. But you need to match the data frame. The dates, if you can combine by dates, that's fine. But what if you combine consumer by product, then you need to using the product name or what's the barcode or whatever information you use that as the primary. It depends on how would you join the data set. So date for the COVID case, we want to match the mobility to COVID by date, so we join it. That actually, if you think about it, if you really want to do COVID with mobility analysis, you do it day by day is probably inappropriate because it takes time for social distancing to have an effect on COVID. right? So even in that case, even though we merge them by date, when you actually do the analysis, day-to-day comparison is probably not the good way to analyze the data. So it depends on the actual data. Melded actually doesn't seem to be the correct answer. So the merge is often we use, but when we merge two data, you need to find out how you are going to merge them. So
merge X, Y
by something. Yeah. So. Okay. And how this is again the more like you can just say the write it more general. How would you find how many counties in Tennessee using from the COVID data set? And this is not a closed book. You can actually check the. Yeah, you can Google or look at your notes code from last time. A few more I will start to discuss. Okay, that's good enough. Let's see. COVID, yes, that from the John Hopkins data set, yes, that's sufficient because the apparently John Hopkins data set it put every county as a unique row, so that actually is working. Yeah. Maybe I should make this question more challenging. If I change that to Google mobility data set, this question will be a bit more challenging. Because the John Hopkins data set, apparently every row is unique. Yeah, so I think next time I will change it, make this question a bit more challenging. Right now, those answers are correct. Yeah. So, okay, very good. Many of you remember how to do this. So we have tried to do simple overlay plot by now, probably at least 2 lectures now. See how this is a question. See how many of you can just write it out. How do you do an overlay plot using ggplot? You don't have to write perfectly. You can write kind of pseudocode, and in principle, how we do that. I'm not looking for perfect syntax here, so. Basically, you can write a pseudocode, and principally, how would you do that? Someone answer very fast. Once it reaches 5, I will start to discuss the answers. Okay, one more student, one more answer. Okay, good. Let's see. No, that is not right. Okay, if I combine them, maybe I'll go down. It look like you need to first melt them. If you want to do an overlay, you have to melt them. So apparently, I only see one good keyword here. So you first need to melt the multi-variable you want to overlay into one column, and then use the category on the side, and then color it by that label. Yeah. Okay, it looks like we need to do more repetition on this. Actually, this person seem to remember this. You first need to melt, then ggplot the melted one. So yeah. Okay. Okay. This is something we really have to work on. Okay, that's good enough. First melt, then plot. Yeah. So that's in principle, that's what we should be doing. Okay. So let's move on to the next question. Okay. So now we start today's chapter. So let's see. Okay, so today we are going to start with chapter 4. We are going to retrieve the weather data from COVID, weather data from Hamilton County, Tennessee, and then merge or harmonize them, combine them with the Google Mobility and COVID-19 data set. Okay, before I do that, how many of you have heard of NOAA before? If you heard it before, can you describe what does the NOAA do? Let's just see whether. In fact, you publish national. Oh, okay, someone probably Googled. Yeah. Yeah, NOAA is where we get a lot of global-wise the weather or atmospheric information. Yeah. Okay, that's good enough. That's how we are going to get the weather data today. We are going to retrieve the weather data from the NOAA portal. So. Okay, very good. So how, before we do that, actually, we need to know the geographic location of Chattanooga, Tennessee. How do you find that? I hope this is probably something from geology in your middle school class. So how do you find out the latitude, longitude of Chattanooga, Tennessee? What? Yeah, this is urban question. I don't remember this myself. So you can just put this on Google Map and see yeah. Aha, very good. A lot of people latitude. Yeah. And it's actually minus 85 because this is west. Apparently, the GIS system east is positive, west is negative, and north positive, south I guess will be negative. I guess so, and there will be 0 at the equator then. So okay, very good. So so what I have, Hamilton County, Chattanooga, I have the latitude 35.17, longitude minus 85.15. In fact, the 1 degree is so large, it really doesn't matter. A few decimal point off really doesn't matter. So that's how we get how we're going to retrieve the weather data from NOAA. We first need to retrieve how many stations have the weather data. So once we run get matter, by the way, if you want the most recent code, you can actually go to the course website, download the most recent zip file, and then you can actually run this in RStudio. in this case, let me just, so then you will have, again, have all the chapter there. 1, 2, 3, and I clear out all the results. You can run it yourself. Actually, it's running. So in this case, I'm going to just let it run, and so I can. But I already generated running result before the class, so I'm just going over the code and running it out without waiting for it. So okay, so it looked like once the closest weather station to this the latitude longitude I get is the first one is something called Lowell Airport. Apparently, many of the weather station is located in an airport. I guess that's the most mission critical place. You need to keep a good weather there. So for airplane to land and take off, I guess. Yeah. So okay. So apparently, when if you want to retrieve those information, there's also a lot of code you have to use. You have to use something like the USAF, WBAN, those kind of code. Honestly, I really don't know what that probably has something to do with the Air Force, but what is WBAN? I don't really know. But it really doesn't matter. Those are the keys, primary keys we use to retrieve the data. And so I'm going to just take those keys, the USAF, the first row, that code, and then the WBAN code is on the first row, and put them together. That's the code for Lowell Airport. So then we retrieve the data from the NOAA portal. So yeah, this actually will take maybe a few minutes if you, especially if you are working at home, have a slower internet bandwidth. So, but it usually takes a 1 or 2 minutes. You should get the data. So in this case, because we're analyzing the COVID data, COVID started from early 2020 in the US. So I only retrieved the 2020 and 2021 data. That's enough for our analysis. So once you let it run, get the data, you should be able to see the most recent data set. Apparently here, today is, that must be when I probably run this last night. So I got it August 30. But there's a message in the chat window. Let me see. Lowell, yes, Lowell is the Chattanooga airport. Yeah, thanks for that clarification. Yeah. So I guess we call it the Chattanooga Metropolitan Airport, but in the airport industry, I guess they call it the Lowell Airport for some reason. Okay, so I'm not sure if actually if I go back to my R code, let me see. So I get the most recent date. If I see those are the code I just run. Let me see today's weather. That's a Google model too. It seems to still August 30. Okay, I guess the weather updating isn't that real time. Yeah. Today is September 1st. I still got August 30th as the temperature, the weather there. I don't have yesterday. It's the day before. So yeah. So okay, that's fine. It's good enough for our analysis. So let me make sure all of you get the if you anyone have trouble to get that data? You can raise your hand on the Zoom chat window if you have trouble. If not, I'm going to move on. I don't see any hand raised or question in the chat window. Oh, someone is still loading. Okay. Okay, good. I'm going to move on. So it may be slower, but at least it is loading. So once you got, this is actually, even though it is slow, the data itself is actually not that big. It's not something I would call it big data. It's relatively big, but it's actually not, by the big data definition, it's not that big. So this is because the data actually is by hour. That means there are only 24 data points per day and 365 days. So it's really not many rows in a year. So yeah, it just takes time to retrieve from the portal. So, but then we have a problem here, right? So we will have the weather data for 24 points per day, but COVID data, we only have one COVID count per day. So we can't really merge the weather data with the COVID data. The COVID, we just say, today we have, say, 200 cases. We don't say at 2 a.m. we have how many cases, at 3 a.m. how many cases. We really don't do that. It's really pointless to do that. But the weather, apparently, we do, because the weather goes by day and night, it fluctuates the temperature. Also, the rain really doesn't do it on the okay, on the long time scale. It's really rain maybe at 2 a.m. then 3 a.m. it'll stop, right? So the weather is actually more fine-grained. That means if we want to merge the weather data with the COVID data, we need to, well, we need to upsampling. We need to shrink the weather data and then merge with the COVID data. So how can we do
all
that?
the hours together?
Oh, someone say what?
Bind all 24 hours together into a day?
Very good. Yeah, we need to, I guess one obvious way to do that is just calculate the average of that. And that actually really depends. I know there's some people study GIS here. Some actually GIS person, they don't do that. They actually just take, say, 3 p.m. in the afternoon. They think that's the most representative temperature of the day. And so it depends. In this case, what I'm going to do, I just group all the 24 points and calculate the average. You could group all the 24 and calculate the median. You could take the maximal or minimal. It depends on the situation, right? If you study how cold a day is, you may want to take the minimal. If you want to study how hot the season is, you may want to take the maximum. And I don't know, but in my case, I'm going to take the average and see how it goes. Right. So how are you going to merge or average a data set? Apparently, there are many ways. In this case, what I'm going to do is actually, do the average. So this is we do a simple plot just to see how in this case, I plotted the dew point. Dew point basically is the temperature where the water will condense on solid surface. So if that is high, that means humidity is pretty high. That temperature is low, that humidity is low. So it's just a measure of humidity. I plot the dew point. Did I plot other thing? No, okay, I just plot the dew point. Okay, that's fine. You could, no. So we are going to just take the temperature, dew point, and relative humidity for the COVID-19 data analysis. There are actually many other, there are precipitation. There are something I don't even know what they are. Yeah, I apparently the NOAA provide a lot of data. I don't even know what those things are. Yeah, but we are going to use the air temperature, dew point, relative humidity. Those are the variable will be informative for us. So yeah. So okay. So now in R, we are going to calculate the average using something called group by. So now group by basically using the same label for all the rows, and then we group by that label. Now, if you look at this data, those have hours, right? So it's August 30 to 2 a.m. or 33 a.m. That means each row has a unique date, and we don't want those unique time. We only want the date. So we remove all those hour information, but leave only the dates as date. That we are going to group by the date, not by the hour. Am I making sense? So basically, well, there's actually a question on it. So you can do this exercise, then I answer the question. So what I'm doing here is we have the weather data, and those weather data is just the date, temperature, dew point, and relative humidity. We're going to group by what? Year, month, and the date. Year, month, and the date, that's the date. Not hours. We are not grouping them by hours. So after we group them by, we summarize all those numbers by the average. If there's missing data, we just ignore them. So this is this line of code does. After we group by the date and do the average, I'm going to save it in a different data frame. I call it weather local 3. And this is just the last few rows of that average. So August 30, average temperature 26.5, dew point 22. It's pretty humid, I guess. Wait, is that August 30, 2 days? Is that hurricane raining? It maybe, hopefully. Relative humidity is 76%. It's also pretty humid. Yeah. So that's what I have. Okay. So, and then we can actually do the average of the temperature and then see how it look like in the last almost 2 years from 2020. So 2020, the temperature, well, in January, it must be very cold. And then that must be April, May, something. Well, not surprisingly, it's very hot around 4th of July. That's and it goes down. That's the holiday. Then coming up again. The good. It looks like this year is not as hot as the last year, is it? It seems to be a bit lower. And maybe that's a good thing. Yeah. So that said, remember, we take the average, we average it out. You might want to try it again if you take the maximum. The average load not necessarily means the maximum is lower, right? Because you are smoothing things out. Yeah. So we could have a spike, high temperature days, but we just smooth it out. Right. Although it looks like the spark here is also pretty high here. 30 something, but this one is almost there, but it's not as high as that. Yeah. Anyhow, you could take the maximum and see how it looks like. So, okay, so now let me see the next question. So based on the example we just go over, you actually can also study the health. So on the R, you could also look at the group by help information. You can also try to look at that help information, answer this question. The question is, based on the example of the help information on the group by, please describe what you think this group by does. You can also Google, I mean, look at other information. This is basically to make sure everyone is participated in figure out how this group by, how it works in R. Right? So maybe a Google page is more informative than the help menu is provided. That's actually often the case. Okay, so let's see. Groups, data frames, so you can perform a frame. I guess philosophically speaking, yes, it's correct. But I wish a bit more detail. Group by take an existing table and converting to a grouped table where. Okay, this is one actually is more informative. Yes, yeah. So this one will certainly have more information than the other one is more philosophical in a way. So if this is a computer science job interview, if you answer with more detail, it shows you how you understand how it works. So if you answer very abstractly, that would be a bit more, people are not really convinced to know what you are doing. Right? So go by take existing. Oh, that's the one. That's actually very similar. These two answer. I hope the other student didn't just copy paste that.
It's via the R help tab.
Oh, that's from the R help tab. Okay, I see. Okay, I see. That's why. Okay. Oh, are you saying this is the official definition of group by? Let me see. Oh, I see. This is kind of obscure, isn't it? Group by taking listing table and converting to group by table where operation performed by bank group. I wish this description could be a bit more informative. Well, but I guess you can't really argue much. That's the official definition of it. But that's like this is just someone wrote it. I think it can be more clear, I guess. Yeah. So
how would you change it?
I don't know. I mean, I'm not an English major. Many of you actually use English as your primary language. Hopefully, you can do better. So, yeah. So, okay. Well, I think the next question. Let me see. My next question will probably is the summarize. Did I? Yes. So when I apply group by, I also use a command called summarize. In fact, the group by and summarize are often combined. Otherwise, it's actually, if you run group by without summarize, you will see it's actually not that useful. So in this case, hold on. I'm not showing the right window. Let's see. Oh, here. I use summarize if it's a numerical, that's because date is not it's really hard to average the date, right? So I'm not sure even what that means. If you, although it could be, or if you average a weekday, maybe the middle is the one you're supposed to get. So,
Hey, Dr. Shin.
yes.
In that line there on 510, it says group by, and I just see one argument being defined. I thought there was two for group by, where you had to define the data.
Hold on. I'm sorry. I changed the window somehow. I jumped.
No, it's 5. It was like 510, I think. It was like line 5 or no.
Okay. I got it. Yeah, 510. Okay.
Yeah. And it's maybe a dumb question. I'm just trying to get clarification.
Can you repeat your question? I don't think I get the.
Sure. I'm just where it says group by and you've got YMD. Is that the data frame that you're calling?
No, that's not. The data frame is this weather location.
Oh, okay. I see.
Yeah.
Okay.
So let me. Okay. I'm glad you asked. Let's look at that data frame. You will see there. YMD is a column. So the date, the original date is say here. It has a date, but it also has hours. But we cannot group them by the date and hours. We need to only group by the dates, the actual date. So we need to remove all those hours from the data information, and then do group by. The other argument. The other variable, air temperature, dew point, relative, those are the value we need to average. So this is the data frame, weather local 2. It's called weather local 2 because I removed many other weather information like precipitation, visibility, ceiling, something. I don't even know what it is. So I just removed them. Yeah. Probably not relevant to COVID. It's really up high in the air. So, yeah. Okay, so yeah. Okay. If I go back to my question, what do you think the summarize if is doing? You can also look at the summarize if health information. So let's see. You summarize if. Oh wait, this is really dark. Hold on. Okay, now it's I don't know what. This is a summary if health information. There's actually a problem here. This part of the problem of probably many computer language. I wrote the code last year. This year is a warning. This command is superseded. You shouldn't use it anymore because in the future it may disappear from the package. So, yeah. But still, it's the future, the new version actually related to this, even though this command itself will may disappear. The new command is actually related to that. This function is like every other group by and checking based on condition. If the condition is true, yeah, that's actually very good. The first answer seems to be describe what this function exactly does. Yeah. Summarize if. Yeah. So. Very good. This is some. This doesn't look like the copy paste, is it? Well, that's whoever wrote this answer, you should try to write a new definition for group by. So this person seems to use his or her own language to summarize this. It doesn't look like this is from the help information, is it? Yeah, very good. So someone can write very well. Yeah.
So is it essentially a map? It's almost like map, but with a condition applied to it.
No, this is not a map because you are reducing the
Oh.
dimension, right? Yeah,
Right. I see. It's
yeah,
not,
this is not a mapping operation. Yeah.
gotcha.
Yeah. Yeah, very good. I mean, someone really know how to write. I mean, summarize. That seems not to be correct. Although this is much longer, obviously, than that statement. So this is whoever wrote that seems to be a very good writer. So I have to admit I won't be able to come up with a sentence that succinct but also clear, I guess. So very good. So yeah. Okay. I think this is. Yeah. Okay. That's a good exercise for this part. And so if that's the group by and summarize, and then we can actually now plot this average. I think I go over this plot already. Yeah. So excuse me. Now we can actually merge the weather data with the COVID and Google mobility data. So now we have the weather data with just one number for every day. So each row we have just one day we have in one row, and then we can just do what? Merge. Use the merge function, merge the COVID data and Google mobility data with the weather data. So the weather data is there. I merge by what? By the year, month, and the day. And I'm also going to take everything in the weather data into the Google mobility data. Wait. Oh, why you false? No, why I choose false? Oh, I know. This is because Google mobility data usually is not updated. It's truncated compared to weather. Weather is actually more updated than Google mobility. So weather will have extra rows compared to Google mobility. So apparently we choose false. Otherwise, it's going to put missing data into the Google mobility rows. So that's why I choose false. So, okay. So once we have that, I'm going to rename the rows by the data again, just to keep our mind clear. So if we manipulate the rows won't missing the label. Right? If the row name and the date mismatch, we will have trouble. Right? So this is just my way to use two different features, keep track of the data, make sure it is consistent. So it's a good habit, even though it seems unnecessary, but it will keep. It's easier to keep our sanity together. So yeah, it may seem necessary, but I always does this to use two different ways to label the data, just in case something went wrong. So yeah, at least you have two different ways to keep track of data. So yeah, so okay. So that's the row name, that's the date. So when they are all matching, and well, hopefully everything is fine. So yeah, so okay. So there, and then in this case, even though I use that, I'm also going to double check, make sure make sure the row names are also matching. So once we do that, you will realize there's extra data information in that. So I'm going to drop that extra data information because we don't need that anymore. So and also those names are very long. If you do a plotting, it's going to have a very long name on the figure legend. That doesn't look nice. So I'm going to shorten those names. So I shorten the labels. So for example, retail recreation, what did I call it? I just called it retail. Residential, I just call it residential. Workplace, percentage change from baseline, I just call it workplace. To make it shorter, so when you do a plotting on the figure, you don't have to have a very long name. A shorter name is more clear on the figure. So there, I shorten the label. Yeah. And then I drop that the extra date and just say select minus that date. I drop that the extra column of the date. That way, when we do the plotting, especially when we want to scale all the data, it will be much easier. Otherwise, with the data in between, it's a little tricky. I mean, it's not, it's doable, but you have to put extra parameter there to do that. Yeah. Okay. And I'm also going to pick a time window because otherwise you plot the 2 years of data, it's really hard to see. So I actually just to plot the August in 1 month. Today is already September 1st. So I'm going to plot from August 1st to today, which is 1 month. So actually less than that because the Google mobility converter data ended that yesterday. So yeah. So I take that time window. And how do we do the overplot again? We first need to, excuse me. I don't think I got COVID, but still, it's good I have mask on. I think that's because I talked for almost 1 hour without drinking any water. So that's what happened. So, excuse me. So we are going to overlay 4 variables. So those are the variable I'm going to melt. That's a melt command. Which table I'm going to melt? That's the tb.local. That's the table. That's basically that. And the column I'm going to melt is daily case, air temperature, workplace, and the residential. This actually is easier to write because I shorten the name. If it's a long name, this line of code will be very, very long, remember that. And after I melt it, I'm going to call the values measurement. The variable, I call it a type. What does it really mean? If you look at the melted table, what's that melted table is df_temp. If we look at this one, this is how it looks like. That's the type, that's the measurement, and those will be daily cases, and then goes to air temperature. So basically, it's going to melt all the values in one column, but those column name will become the color labels on a different column. If you compare this there, the variable name basically means what are the variables? Those are the variables. Daily cases, air temperature, workplace, residential. So that's the DF temp there. Daily case, air temperature, workplace, residential, there, residential. Those are the 4 variables there in that column. And the variable, the values are in the measurement. So the value of the name is in that measurement column. Does this make sense now? Hopefully, it next time when you answer how to do the overlay, you remember the melt command. So yeah, we put that into a new data frame. I call it df_tmp, and then we do a ggplot. Now the ggplot we can also actually assign into a variable as well. Because ggplot is additive, we can assign to a variable, then plus additional command. That way you don't have to type a long line with everything there. And so you can just type 2 short lines. So there is actually another advantage. Once you assign it to a variable, that means you can change parameter, make a different plot. If you're not sure what kind of plot you can actually do, you have the base plot, but with additional command to do different type of plot to see which one looks better. That's actually, there's another, one of the reasons why ggplot is popular. Once you assign a plot to a parameter, you can actually do programming on it, right? So that's actually another advantage of the ggplot. So, but when we can actually assign that plot into the variable and then change it later on. So, okay. So I'm going to do the plot of that df underscore temp, and the y-axis is the date, year, month, and day, and the y is what, a measurement, and color by type, and then add a smooth line, and then I put a title of the location and the state there, and this is how it look like in August. Does this actually meaningful? That looks very odd, isn't it? The orange is the daily case. Wow, this is weekly cycling is quite obvious, isn't it? Once it on the weekend it dip. Once the week started, it goes up. It almost like the virus is have a work on the weekday and take a rest on the weekend. So this is, if you just look at the case data, it looks like the COVID-19 must have a job something, yeah. So it looks like this infection is a job something. Sorry, I really shouldn't do that, but that's, yeah. But then you look at all other, it looks like the temperature is a flat line. There's no change at all. And also the mobility data, like worker, they're also all flat lines. Does that actually make sense? Yeah. Yeah. So what next? What can we do better? Yeah. Yeah, we should scale the data, then do the overlay. Right. So this is actually, we plot the raw data without any scaling or normalization. So that's what happened. Yeah, because while the case data is several hundred, and the temperature you have it, the Celsius is just 30 degrees are pretty hot. 30 degrees like 100 Fahrenheit. That's relatively small. And the workplace and residential mobility, that change. And up and down, maybe 30, 50%, those kind of range. And if it's a normal, that means a 0% change. And that's actually why you see those close to zero. So you won't see those change. Once you plotting data on completely different scale, it's not informative. So even though that's actually is an accurate presentation of the data itself, but it's actually is not telling the story, because the human eye just cannot see those subtle changes, right? So yeah, if you don't see a subtle change, even though it is there, but we assume it is not there, right? Okay, so now we actually need the next part. We're going to scale the daily cases, mobility, and the weather, and then do the plot. So we change that into a major numerical scale and put it back, and then just melt it again and then overlay. So this is how it looks like now. It's look at everything is oscillating now. This is because both human and the virus now have this weekly schedule fluctuating, which is really odd. Really think if it, without any analysis, you think something really, you can make up a lot of theory to explain those things, right? So you have the daily cases now still oscillating. You have the workplace, of course, it's oscillating because in the weekend people don't do good work. And the residential is also going to oscillating because people, if you go to work, it's going to down the residential. So these two are oppositely oscillating, right? So everything is oscillating now except the temperature. hopefully the temperature doesn't do that. So everything is oscillating except the temperature. So this actually seems to make sense. Yeah. So now I'm going to ask you this question. Oops, sorry, that's not it. No, I'm trying to look for my Socratic question. Here, yeah. So now, can you write your view or your opinion when we should do, when we should not do a scaled overlay plot? Okay, let's see. First opinion. Data should be scaled. This. I should be able to freeze the window, read it before it jumps in. I'm not sure how to do that. Maybe in the future, this service should add that feature. Yeah. You should scale over the data when the data does not look meaningful. Let you compare the variable noise. Data should be stored if data changes too subtle. Maybe, yeah, so variable. I guess those are more or less. I don't think I will write a better sentence, to be honest. Even though I'm the one reading the. If I'm the one answer the question, I would say. It depends on the plotting of the data on. It depends on the scale of the visualized data to be visualized. If the data in different range, we need to transform them into similar range. Actually, scale is probably a wrong word here. Are we going to transform the data? Maybe that's a better way to. It doesn't have to be scaled. It could be just moving up and down. It could be you can just add a constant for another variable, just move it to the same place. Yeah. Or there's actually another way. You can change the y-axis. You can do the plot without the transform, but just change the y-axis in the plot. There's actually another way to do this. So actually, that's the way I often did in some field. You don't want to change the data, but still want to overlay the plot. So when you do multiple plot, you change the y-axis. You just plot them in the same area. Yeah. So there are actually different ways to even though overlay the plot. But apparently for ggplot, if you put everything in one column, you have to scale it. That seems to be a weakness. I don't want to say it. Although it is possible, I haven't figured out a different way to use the ggplot. Given there are so many fancy products, there's probably a different way to do the overlay. I haven't used it. Yeah, so maybe that's just my own ignorance. How there's some feature I haven't used it. So yeah, but at least using the melt function, you have to scale them. Otherwise, they will be numbered at a different scale. So yeah. Okay. So in a way, this is also a practical question. Yeah. So there are obviously many different solutions to this problem. So okay. Okay, I think we still have about 10 minutes to go. So I think I can now ask you to do a bit more challenging question. So now when we analyze the last 2 years, how about we analyze a few more years? how about we analyze data from 2000, 2005, 2010, 2015, 2018, 20, how about you analyze some data from last week? And then can you make a conclusion? Did the climate really change here? At least at Hamilton County, Tennessee, or Chattanooga Airport. Right? That's, although it probably doesn't make sense, but make any difference? The question is, retrieve all those data and then visualize those data. Do you see some changes? I'm going to give you maybe 5 minutes, something, and then although actually, I mean, my sample code already did some analysis there, so you can just run my sample code to see whether you get something interesting there. It's actually quite shocking when you really look at the data. Yeah, I'm just looking at the last 20 years. At one small town in the U.S., I guess, Chattanooga, and I didn't really expect to see that happen dramatically, but I was shocked when I actually look at the data myself. So, so this is not something you feel something changed. If you look at the data yourself, and you can make the conclusion. Okay, so I'm going to, if you look at it, if you run my code, you probably can see something there. What are your, sorry, my typo. What are your conclusions by exploring the weather data of Hamilton County from 2020 to 2020? You don't have to look at it every year. You just pick a few years. That will be faster. Otherwise, you're going to take a lot of data. Yeah. So obviously, we are not doing a serious, very rigorous, right? Just looking at the data and see how it will look like. We are not doing some climate study anyway. So in any case, it's just one airport. So. Let me see. This is, I'm actually showing some of my pre-run results. So this is what, this is the, what plot is this? This is relative humidity. Apparently it's pretty, Hamilton County, because in the south it rains a lot. So you don't see much change because once it go rain, it's 100%, you cannot go any higher. So, right. So the humidity is really hard to move, right? It's just that 0 to 100%. Once it reaches 100%, it's not going to increase anymore. So in fact, even going down, see here, it's actually even going down a little bit in recent years. The relative humidity actually goes down. How could that be? Actually, if you really think about it, there's some reasons, but that's I don't really study climate. I don't want to over speculate in a way. Yeah. But you do see a little relative humidity that goes down in the last, at least the last recently. So okay, and this is what? This is precipitation. What does this look like to you? This is temperature. This is really shocking when I look at this plot. The maximum amount of rain, the overall precipitation is increasing steadily. And the maximum amount of rainfall in the last 5 years compared to those in previous years, it's really increasing. That's it. I mean, we are just looking at the figure. I don't want to over. So, but at least based on this plot, the maximum amount of rain drop is increasing, but oddly enough, the relative humidity actually is going down. So even though the maximum amount of rain is dropping, there's actually, if you really think about how the physics work, there's a very good reason to explain that. The air temperature is increasing. So, but that said, if you look at the air temperature, it doesn't look like, but that's it. We didn't plot atmospheric temperature up there. So we are only plotting minus this air temperature is what lower to the ground is how we experience. So it's a different temperature. It's not really, in a way, this is not a serious climate study. This is just how the weather reported from lower airport. So this is not a serious climate study, but it's still, when I look at this one, it's quite shocking to see that. Yeah, so, you would think when it rains a lot, the humidity should increasing, but not really, because if the temperature is high, that means water will evaporate much more to the sky. Right? But that relative humidity actually goes down, but then it's just this cycle is just more dramatic. So the odd thing, even though the cycle is more dramatic, it feels relatively drier. That's kind of a really oxymoronic about that's how physics works apparently. So yeah, that's it. Don't trust what I think it is. I'm not I don't study climate for a living. I just plotted some data, make some nonsense talk probably. So yeah. Don't trust my that. But that's it. If you are really serious into that, you may global warming. Okay, both are correct, I believe. Global warming or warming, that probably all makes sense. Someone put in the chat window. So, okay, here's my last. I think I have one more question. Look at this help information. Summarize. Look at this. Some help information. Summarize if. It says proceed, right? Oops, sorry. It says superseded, but why is it superseded? Because oh no. You should use what? You should use across. We shouldn't use summarize if we. The most recent feature is something called across. My question is, can you look at the help information across? That's a better command. People apparently are now says, do not use the summarize if, use across. And my question is, well, now that the R says don't use summarize if, use across. Can we modify that code, use across? Don't use summarize if, use across. How do we, I mean, actually I gave you answer a few rows, a few lines down, but you can try it. So this is one of the things about computer language. There are always changes there, even though, I mean, I wrote that code, in fact, as recent, maybe six months ago, I didn't notice that. I don't, that's it. I guess at a certain point, they are still backward compatible, but I guess at a certain point in the future, maybe it won't be backward compatible, right? So like Python 3.x is just totally incompatible with Python 2.x. So somewhere in the R code, the summarize if probably will just disappear from the language. So, yeah, so now they said use across. How do you use across to rewrite that code? So, yeah, computer languages seem to change much faster than English language itself. maybe not, because in language there's also a lot of word. Like my daughter say a lot of things I cannot understand. Maybe not. But I think I will take that comment back. Maybe English language is also evolving very fast. And in fact, there are so many things in the lyrics. If I really read the caption of some commercial, I just had a hard time to understand. Okay, anyhow, so. So let's see. Well, that's at the help menu. You didn't apply it. Oh, very good. Actually, that's basically what it is. Yeah. Instead of summarize if, across is more accurate because you can specify which column you should do it. So it is more, I would say, become more clear. Right? If you summarize if, that seems to be a bit ambiguous. But across, you can specify precisely how it's going to be operated. So across indeed is the better. It becomes more clear. You are less likely to make a mistake, right? From that perspective. Yeah. So, okay, I think that let's conclude what we have done today. So that's the chapter 4. So we learned to harmonize, integrate heterogeneous data. Particularly, we learn how to use a group by and summarize if, and then across with a better way to average the data by rows and then merge it. So that's for the weather. Then merge it with Google Mobility and the COVID daily cases. We kind of also learn how to identify location with the latitude and longitude, although that's just a refreshing of your middle school geology lesson, hopefully. We also kind of learn why we need to scale the data or why we shouldn't scale the data for overlay in a way. And hopefully you can remember now using ggplot and mail function how to do overlay. Yeah. So, okay, I'm 2 minutes over time. That's hopefully it's okay. All right, any other questions? So if not, I'll see you. This is I have a good week and I'll see you next week. Yeah, so, any other questions?
Thank you.
Okay, bye.
Thank you,
For
Professor.
oh yeah, I hear a question. Yes. Hello. Did someone ask you a question? If not, I'm going to close the room now. Okay, bye everyone.